Good morning, everybody. Saturday morning, Saddle Mountains once again. I'm back. This time, private land. Very generous brother-sister team guiding me up here, and we are enjoying an amazing set of views. The weather is improving, and I just want to shut up and give you a chance to appreciate these views. And I want to just add to what I was discussing before. Holy cow! Can I swear here? No, I can't swear. So I need to emphasize one more time. This is not public. I'm not giving you a GPS coordinate. This is off limits for everybody. But this rare opportunity gives me a chance to share I have to come over here for just a second, if you don't mind. So while I'm scrambling over here and we just have this nice scenery, last weekend you might recall that I was dealing with Lydia Steich's paper having the Snake River coming down through here. I'm just going to come to the lip. Oh, I'm screwing up the route that... Okay, so I need to... So we're looking north across Crab Creek. Crab Creek is flowing right to left. I hope that you can see that there's some impressive scabland here. So there's evidence of the Missoula floods from east to west down through here. You're looking down on Crab Creek Road. There's some muffler boys down there having a blast this morning. And Lydia has the Snake River flowing down through this drainage pre 4 million years ago. And I'm going to continue to add some thoughts to that because I've been thinking about that paper most of this week. But this vantage point allows us to access something within the cliffs, within the walls of Saddle Mountains that tell a far older story that involves Yellowstone. So the siblings have met me out here, and let me add to this concept of the Snake River. You're looking north right now into the Quincy Basin, and coming straight at us during the Ice Age is the Columbia River, because the Columbia River is diverted down the Grand Coulee, over Dry Falls, through the Quincy Basin, Soap Lake, blah, blah, blah. But if you look carefully at Lydia Steich's maps from pre-4 million years ago, she's got the snake coming down the Grand Coulee as well. Now, this is before the Ice Age. This is before the Grand Coulee is the Grand Coulee. This is before the Grand Coulee has steep walls and flat floors and is box-shaped and the whole Ice Age flood story. This is pre-Ice Age floods, and yet I need to work with Lydia a little bit more to see if she really has evidence for that old Snake River coming down a former valley that was probably a subtle version, a subtle river valley that now is the Grand Coulee, but she's needing to get the Snake River here. That's my point. So as opposed to the video I did last weekend, look at this, look at this, look at this. You're looking east. Look at the elevation change between layers that are up here on the top of Saddle Mountains, and some of these layers are down there underneath Crab Creek, indicating that there has been tremendous uplift on the Saddle Mountains fault. There's so much going on here. I'm getting I'm getting too scattered in my commentary because I'm bouncing around between Ice Age, pre-Ice Age, and then even modern day when we have the snake. Oh God, here it is. Okay. Wow. Private land, remember. I can't get you here. Those that know this drive down along Crab Creek, when the sun is right, they look up on this very tippy top of Saddle Mountains and they notice this burgundy or maroon, or I don't know what the color is, deep cinnamon red that the camera's probably not picking up very well, but it's on top of that 30 feet of ash. And that 30 feet of ash continues over here, and here is this brown. I've never gotten my hands on this maroon Cougar Point Tuff. And I gotta catch up with the siblings, but this Cougar Point Tuff is 11.8 million years old, and it is ash from a supervolcanic explosion that happened in southern Idaho. This is ash that came out of the sky from a Yellowstone explosion when the Yellowstone mantle plume was at a place called Bruno Jarbidge, which is a caldera that's mostly buried now near Twin Falls, Idaho. Oh my Lord. Oh my gosh. Thank you.
You fall, you die.
Thank you. No. I'm still rolling right here, sibling number one. On the canyon wrens.
I was telling Sarah that I came over here like 5 or 10 years ago and rediscovered these rock formations here we're looking at.
Yes.
Because my brother and I used to climb around down there when we were teenagers. And I was like, I'm not going down there now.
Life gets a little more precious as you get older.
You get a little smarter.
Right. Wow.
Not so. Wow. This is awesome.
It is awesome. So I'm going to do another quick take on this. Here's a very thrilling take on this ash. This is all ash fall. And, 100 years ago, even 50 years ago, there are geologic reports of this Cougar Point Tuff. It wasn't called that at the time. And they're like, wow, there's 30 feet of ash fall here in central Washington. This ash must be from the Cascades. There must have been one hell of an eruption in the Cascades. And they knew the rough date. They knew the date had to be something like 11.5 million years ago. So they're like, I don't know of a Cascade volcano that erupted 11.5 million years ago. But in the reports, they're like, must be Cascades. Because why? Well, you're downwind of the Cascades. If I swing you around, I swing you to the north, and then I swing you to the west, we do have cone volcanoes, stratovolcanoes on the horizon. So you can't blame the early researchers to just think this is some sort of cascade story. Well, here's the exciting part of the story. This ash was finally sampled by Barbara Nash, University of Utah. She has an incredible database of tephras, ashfall deposits, from across the Pacific Northwest. I don't know if she must have come here to sample directly. And she's like, well, this is not Cascade. This is Yellowstone supervolcano ash. I have the chemistry to prove it. I have the age to prove it. There were a series of supervolcano explosions in southern Idaho. One of the calderas from the Yellowstone mantle plume chain of calderas in southern Idaho, the Snake River Plain, in other words, near Twin Falls, Idaho, the Bruno Garbage caldera. And I know you may not believe me. I think you might not believe Barbara Nash's work. But she has the geochemistry and the precision to say this is 30 feet of ash that rained down, that snowed down in central Washington 11.8 million years ago. And I don't think anybody's saying it was 30 feet of ash everywhere, but here, locally, in central Washington, this ash is 30 feet thick. I did a PBS program on it. There's lapilli. There's other, I mean, look at this. So here's maybe some clues. This is stunning. Here's maybe some clues as to why there's 30 feet of airfall here 11.8 million years ago. And you can't follow 30 feet of ashfall all through the Pacific Northwest. These cross beds here. Wow. I think the speculation in the scientific work is that there's been reworking of this volcanic ash after it snowed down and accumulated here, almost like a snowdrift. The snow got piled up by wind, maybe water, maybe both. I've never, the only other place I've seen this Cougar Point ash is in a pumicite quarry where they mined this to put into concrete. But that was kind of a quarry wall thing. This is more natural for sure. Reworked Cougar Point tuff, 11.8 million years old. And where are we? Are we just next to some freeway off-ramp? No, we're not. We're in one of the most stunning locales in all of central Washington. I sure wish this was public. I sure wish this was accessible to you. I've been fascinated by this story for a long time, and this is my first chance to get up in a natural exposure of this Cougar Point tuff. Wow. Idaho ash. Wow.
So this orange is what you're talking about, where it baked it.
Yes.
Cool.
It's just more of the tan, but the heat from that overlying Elephant Mountain flow just welded the top of this thing. And it's that color that is visible from down on the road. And every group I've had down there is like, what's with the orange layer? And for many years I'm like, I don't know, I'll have to figure it out. And I eventually found the right geologist to help me. Gosh.
You okay?
Well, we're starting to get more rain, so put the camera away, I guess. This brick orange is the welded top, the baked top of this Idaho tuff. It makes it seem that way, at least, yes. That's right. Okay, we got some raindrops, but I have to share this with you because this is an important part of the story and a nice little change. So this is that same Cougar Point ash bed, 30 feet of it. You know the story now, but there's a color change. In the lower portion of this 30 feet of ash, it's pretty white. And then we get a little darker tan, we get some greens thrown in. Right here in this exposure, not much of the cross bedding that we were seeing across the way. But again, I've only really seen this from way the hell down there in the bottom by Crab Creek. So if we're up here high, thanks to the siblings, I can go right up to the very top of this Cougar Point tuff and show you how the color changes. And we can get to the very top of the Cougar Point tuff where the Elephant Mountain flow, like whoops, there's my hammer, it goes down the crack. It's the same flow. Now we're at the very base. We don't have beautiful columns here now. We maybe did once upon a time, but my point is, here's the contact where the heat of this Elephant Mountain flow, 11 million years old, bakes the top of this Idaho tuff. This is a baked Idaho potato. And yet here today, it's still friable. It's still not, so I'm saying it's baked, but it's not, welded into a hard rock. So I'm noticing right now with you, why do we have a vesicular top here? Is this the... I guess this is the it has to be the Elephant Mountain lava, but it has vesicles here and it's discolored here. So in the famous place with the big columns, the Tootsie Rolls, the Elephant Mountain lava is on display, but there's no vesicles. Here we have vesicles. And I guess I'm confused by the deep red of the lava. Look at this. I don't know why this lava is so red. So I'm discovering with you right now that I'm not sure I have the story, and I'm not sure anybody does. I thought this was going to be regular looking basalt, and it appears regular looking from a distance. And I thought we were going to have deep, deep reds in the very uppermost part of the Cougar Point tuff, and then we lose the red and we get into normal looking basalt. But the basalt itself is red. So is the red something secondarily? Is the red that something truly unique? It can't be. Okay. So like usual, the more you drill down to some detailed levels, sometimes more questions pop up. And if you have the wrong mind frame, I suppose that's frustrating. To me, it's just the mysteries continue and it's fun to follow these clues. Okay, this is one of those days you keep putting the camera away and then the weather improves and you pull the camera back out. Video camera I'm talking about. iPhone 13, thank you. You are looking west along the steep north face of Saddle Mountains. Crab Creek down below. Can you visualize the Ice Age floods flowing right to left, catastrophically, creating the scablands? Can you visualize the Columbia River flowing east to west along the north face of Saddle Mountains? And yes, can you visualize the Snake River more than 5 million years ago doing the same thing? That's right, the Snake River coming down an earlier drainage, pre-Ice Age, the Snake River getting to the Snake River getting to the Saddle Mountains and then getting doinked to the west, and the Snake River going down to what is now the Columbia River Valley, and then hanging a left through Sentinel Gap, and finally getting past this east-west barrier known as the Saddle Mountains. Now, what's the Snake River talking about? Well, remember, Lydia Steisch has this new paper, and she came here to study the Saddle Mountains fault. That's why there's such incredible uplift on this side of the creek versus the other side. And yes, down below us in a very precipitous wall is the Cougar Point Tuff that is the main focus of our episode today. I don't see the red, by the way. That's interesting. I don't see the brick red at all on the top of this Cougar Point Tuff here. Why? So I'm now even more confused about the brick red. But my point here is that once we get up above the Elephant Mountain, so this is Priest Rapids lava flow, Cougar Point Tuff from Idaho, Elephant Mountain flow, no columns, no Tootsie Rolls, and then up high, and I think I'll just walk my way up here, is the Ringgold Formation. And the Ringgold Formation is what got Lydia Steisch interested in this Snake River story to begin with. I can just do it right here. No, this is probably some calcrete. That's tomorrow with Sky Cooley, by the way. But anyway, let's continue up. I won't bother. But Lydia was here from the USGS, one of her first major assignments, to study the history of the Saddle Mountains fault. And to do that, she needed to carefully work with each of these layers exposed south of the Saddle Mountains fault and north of the Saddle Mountains fault. Talk about the offset, talk about how much movement has been happening on the Saddle Mountains fault and the age of the earthquakes. And for the first time, she started sampling the Ringgold Formation, which you're looking at with bad light up here at the top, sending the Ringgold Formation to the lab and realizing that many of the detrital zircons had a Snake River signature and not Columbia River or Crab Creek today. I promise I'll watch my step, but to finish, I want you to look down on one of the steepest escarpments in all the Pacific Northwest. So steep that I can't get up to see these layers easily, and you can't either. And that's why this rare opportunity with some help has been such a tremendous, exciting opportunity. Tootsie Rolls and Drumheller channels. Drop the rock hammer down over there. Walking on Ringgold. Honest to God. We're an hour away from Ellensburg, by the way. The hits keep on a-coming. Ringgold, Elephant Mountain lava, Cougar Point tuff with a red brick top, Priest Rapids lava flow down below. Continuing lower down to Grand Ronde lavas in the lower part of Saddle Mountains. You're like, where are those layers over there? They're down there, but they are much lower than here because of a major fault that has created this escarpment. So the Elephant Mountain lava here is the Elephant Mountain lava that's down there along that body of water. So Ringgold, Elephant Mountain down low, Ringgold, Elephant Mountain at the very tippy top. Looking west. And it disappears in the next wall. There's so much that I don't get. Why doesn't that brick red continue? Why does it stop and why does it start? And is the brick red basalt? It's almost like the brick red is in the colonnade at the base of the Elephant Mountain. It looks like that from here, but I don't get it. The Cougar Point tuff at the very top of Saddle Mountains. Thank you, I love you, and goodbye.